Welcome. I am Vaasanth, studying EC at VIT-AP University in second year and an IoT intern at Emertxe Technologies. Now we are going to discuss about the smart factory IoT monitoring system, our project, and how it built, why it built, and what is the decision making inside it. Before going to this project, let us get a brief idea about IoT. What is IoT? IoT is a network of things, the physical systems that communicate through sensors and processor over internet. The framework of IoT has a sensing, the perception, transport, connection, intelligence with the computing, with the data processing, and the user interface with the action. Sensors get the data and transport this data through connection with the protocols, and the microcontroller processes this data, and we can monitor this data throughout the world through internet. And why IoT as a solution? Because it has a real-time monitoring of the data, and the decision was taken based upon the data automation of the things. It will by setting up certain rules, we can automate the things easily, such that we can get as our desired solution. And our IoT solution is the same because it was encrypted with the cryptographic algorithms, and everyone can access from anywhere in the world. The problem statement goes like this: why we are beginning this project? Because in the real world industries, due to the lack of real-time accessibility of data of temperature and the mission control, there is a lot of damage to the machines and the spillage of products. To ensure that, we are proposing a solution where is a multi-modal solution. We are collect the data and interface with the IoT devices through cloud platforms. Here, we have Node 1 and Node 2, which is production line 1, and production warehouse line, which is the Node 2. We notify through alarms when the certain conditions were more than the set one, and temperature exceeds more 35 degrees Celsius, we trigger a critical alarm. As the vibration goes when there is a reading of potentiometer more than 700 and the humidity more than 80%. Now let us go into the data flow of this uh, project. Sensors like a DHT22, LM35, potentiometer, PIR sense the data through the real world. Potentiometer is being used because there is no vibration sensor of MPO6050 here, and the, these sensors collect data and send through microcontroller, which in our case we are using Arduino Uno, uh, which receive this sensor data and send it to the microcontroller, and to on this send microcontroller sent to the interface we use a communication protocol MQTT. And now let us go to system architecture. The system architecture goes like this: the presentation layer, which is the user interface layer, it may be a web dashboard or a API or a mobile application, and down it was built on the application layer, the things board, alarm manager, rule engine, and which was application layer which was built on this Node 1 production line, Node 2 warehouse line, the sensor layer, so DHC22 LM35 PIR LDR, Node 1 as DHC22 for the uh, environment temperature and humidity monitoring, LM35 for the machine temperature monitoring, potentiometer for the vibration, accumulators, LEDs and relays for the warehouse 2, DHC22 for the same temperature and humidity monitoring, LDR for the light detection, PIR for the motion detection, human motion detection. When the humidity exceeds more than 85%, the alarm triggers and the relay enables ventilation such that the humidity gets low. And here we use MQTT protocol, which works on the publication subscription model. This is connected to Ethernet as Arduino doesn't have any Wi-Fi inbuilt. Now we'll go to the Node 1 code and the cloud platform, and this is the Arduino IDE where we wrote the code of Node 1. And now let us go into the Node 2. This is also same the code, the modifications. Now go to the Pixim Lab simulation of Node 1. Here we can see the Arduino Uno board, and go to the spare parts now. This spare parts we see as virtual terminal was open and got connected, so red LED got toggled to green. And now let's open the cloud platform for that. And then we can see here, yeah, yeah. Now we can see the temperature variation of 31.4 degrees, and so yeah, we can see the analog gas 31 degrees Celsius. Now go to the 63 degree percent is the humidity. Yes, yeah, yeah, it's the same showing here. That. So, and now let us go to the alerts. This was triggered at the not now. This is before half an hour. So, uh, now let us go into this mission status. Relay was off now as of there is no relay triggered. Sensor error, there is no sensor error, means no sensor got misplaced or disconnected. This is a time chart time where we can see the temperature, humidity, and the different emission status relay, all the readings. The data get updated at every 5 seconds, and this is the relay switch. This is the time series chart. We'll see this later. And now let us hit the mission control. When I toggle this switch, let me show you clearly. It's continuously. Yeah, I can see that now. When I toggle this switch, this red or green LED goes off, which this shows that the machine was off in off condition. And again, I press it on this machine got on. So like this, you can remotely turn off the machine. I want to trigger the alarm, increasing the temperature. Now it was 79 degrees, point 4, 79. Yeah, it should get triggered. It should trigger. Using LM35 humidity also. Right, triggered. Now going for the Node 2 Pixim Lab simulation. Node successfully completed. Now go to spare parts of Node 2. And yeah, as we see, the reiterated LDR, and I'm check the reading of humidity as 34 percentage. Yes, 34. And LDR, yeah, it's 136 LDR value. Is it dark? Yeah, it was dark. Mostly detected. There is no mostly detected. Let's trigger it out by switching or toggling the PIR sensor switch. I'm clicking on it. Yeah, there is a motion sensed. It is going to on. Okay. Now, as long as I have pressed, also on, sing on. And yeah, when I again toggle on it, it got off. So this is how the motion got detected in this. There as well there is no sensor error. This is time series chart showing the humidity was remaining constant for the past. This is time series table. Getting data of all this sensor. Let us trigger the alarm by increasing humidity. As the humidity got increased, the ventilation relay got on, and it was open the ventilation. And you can see, yes, it got triggered at 21. Yeah, so that's the time now. Let us lower the humidity. It should reflect in the readings. Now I want to show you the yellow LED working by sensor error. You can see the yellow LED got blinked. Yes, yeah. You can see the green blink of this sensor error. Again, bring to the 4 pin 4. The yellow LED must turn off to pin 2 sorry, pin 2. Got turned off to the proper connection. Sensor error must go, yeah. This time series chart of the node 2. That's showing the humidity change. Let us go into the Smart Factory dashboard. Combines all the node 1 and node 2. Now first we'll go for the node 2 warehouse. You can see the humidity showing 25.5, which is right now. The door open, one is dark as one, shows that both are working correctly. Motion detector 0, no they are not detected. Sensor error 0, there is one sensor error. Let us go for the node 1. It's a production line. Temperature was 17.4 as of now as we started meeting. And humidity was 9.5, 11:35. Temperature was 149.1. And the status as of now it is working, showing 1. Relay status is 250. Sensor error is 0. There is no sensor error as of now. Let us go to the time series chart of 11:35 temperature and temperature from this DH22. Yeah, you can see the temperature chart here. Temperature comparison between both the amplifier and the temperature from the DH22. And this is about the dashboards, the project for smart factory IoT monitoring system. Now let's discuss about the technical stack. The programming with C, C++. The libraries are PubSub client, Arduino.h header file, SPI header file, Ethernet header file, DHT header file. The communication protocols is MQTT over Ethernet, SPI. For Ethernet, we have used the W5500 in the Arduino and the platforms so used are Arduino IDE with the programming fixing lab. You know, my learning from this internship was this uh, real-time learning apart from the academic theory. I got to know how to use a MQTT protocol, the cloud communication, and I can this gave me confidence that to build real-world working systems in the future, and and this project can be multiplied into multiple nodes. And by using the Pixim lab, we can know that simulating first and rectifying our errors on the software helps us to give error-free solution on the hardware, which is very crucial for saving hardware and getting experience without it soldering. And uh, it, the Emertxe also helped me to go through the industrial experiences from the mentors, and these opportunities were very insightful and useful for career growth as of me. And yeah, thank you, Emertxe, for this opportunity.